Hello, everybody. Welcome to Science Abounds Science at Home, where we will discover home lab magic. We will be doing experiments demonstrating scientific principles, concepts, and reactions in chemistry, biology, microbiology, microscopy, and even forensic science. Welcome to my channel. Hello, everybody, and welcome to another video of Science Abounds Science at Home. In today's experiment, we're going to look at the analytical chemistry technique of titrations. And titrations in particular, we're going to be performing an acid-base titration, a very simple demonstration of the technique of a titration. And the titration technique uses a glass cylindrical piece of glassware that I've got here with a tap at the bottom to control the liquid. And this is called a burette. And the burette is a laboratory piece of instrument glassware, and it is used widely in quantitative chemical analysis to deliver precise volumes of liquid, and is used primarily in titrations. The key features of a burette is that it is a long cylindrical glass tube with a stopcock at the bottom and is marked in millimeters with 0.1 ml graduations, and it is calibrated. These are calibrated glass tubes and allows for controlled release of liquid drop by drop. And these are calibrated similar to glass pipettes, glass volumetric pipettes that you see in most chemistry laboratories to deliver precise amounts of liquid. In this lab, we will determine the concentration of a solution of hydrochloric acid by titrating it with a solution of standardized sodium hydroxide. Okay, so I know we have a standardized, so I've already made the solutions beforehand in the interest of time, and I've made a standardized solution of 0.1 molar sodium hydroxide, and I use graduated glassware and an analytical balance to weigh the amount of sodium hydroxide and to deliver a precise volume of water. So this solution is as close to a standardized 0.1 molar sodium hydroxide solution that I can make in my home lab. In addition, I made a rough or estimated solution of hydrochloric acid where I did not use graduated volumetric technique or any analytical balance. I just pipetted a volume of concentrated hydrochloric acid using a plastic pipette, and then I just poured in 250 mLs of water using a measuring cylinder, which isn't calibrated, but it's estimated. So I have an estimated 0.1 molar hydrochloric acid solution. So what I want to do now, using the technique of titration, is to get the actual concentration of the hydrochloric acid. So what I'm going to do first is to fill my burette with sodium hydroxide. Now, the neutralization reaction between hydrochloric acid and sodium hydroxide is a 1-to-1 molar reaction. So my 0.1 molar sodium hydroxide should neutralize 0.1 molar of hydrochloric acid. And we determine the endpoint by a color change because we're going to add a couple of drops of a pH indicator called phenolphthalein. And when phenolphthalein changes color to a pink color, this indicates the endpoint. So what I'm going to do now is I'm going to add the sodium hydroxide to my burette. So I've got the top of my burette and I'm going to pour in about 50 mLs of sodium hydroxide into the burette. So I got my graduations here. So I'm going to try and bring it up to 0. Like so. So what I want to do is I want to bring this and level out a volume of liquid. So what I'm going to do is open my stopcock to drain out some of the liquid, make sure there's no air bubbles. And then what I'm going to do is I'm then going to focus and bring down the level of the liquid so it's level with one of the graduations. Now what you're looking for is that when the liquid is in the burette, it forms a curved meniscus. And the meniscus refers to the curved surface of the liquid inside the narrow tube of a burette. And this curve forms due to the adhesion of the liquid to the walls of the burette and the cohesion between the liquid molecules. And what you're aiming for is the bottom of the meniscus must be aligned with a graduation mark. And wherever the bottom of the meniscus falls is your numerical value of how much liquid there is in the burette. So I'm going to do that now so I know exactly the amount of liquid I have in my burette. So I've aligned my meniscus to the level of 6. So I'm starting at 6. So the graduations of the burette usually go from 50 to 0. So when you drain the whole burette from 0 to 50, you know you've delivered exactly 50 mLs of liquid. So my starting volume is 6. So I'm going to record that on my log. Okay, so starting volume is 6 mLs. So next what I want to do is I have a conical flask and I'm going to add 25 mLs of hydrochloric acid, 0.1 mLs. Oh, sorry, I need to use a different cylinder. So I want 25 mLs of hydrochloric acid, which has an estimated concentration of 0.1 moles. But we don't know for sure until we've done the titration. So I'm going to add that to the conical flask. And then I'm going to add 2 drops of the phenolphthalein indicator solution. 2 or 3 drops. Okay, I added 3. That's fine. I'm just going to give that a swirl just to mix that. And then I'm going to slowly add. I'm going to lower my burette a little bit. like so. And then I'm going to start adding the sodium hydroxide carefully until such a time that I start seeing more and more pink. And then I'm going to slow down and start adding it dropwise, because the more pink you see, the closer it is getting to endpoint. And we don't want to overshoot the endpoint by adding too much. Otherwise, that will skew our calculations. Okay. And what we're looking for is for the solution to change to a permanent pink color. And that is our endpoint. Okay, so now I'm going to start adding the sodium hydroxide. And you will see at the point that it contacts the solution, it does give a pink color. I'm going to just lower my burette down a little bit more. Okay, so I'm going to keep adding it. And as you can see, when I add it, it turns a little bit, a very faint pink color. So we're not there yet. So we add a little bit at a time, mix it, keep adding until the pink gets more and more intense. And we keep mixing and the pink goes away. We keep mixing. Okay, so the pink is getting more and more intense. So we need to go a little bit slower and not add so much sodium hydroxide. So we want to avoid overshooting the endpoint. Okay, we're getting there. So now we're going to go add a few drops at a time because we're getting very close to our endpoint. And also when you see the pink getting more and more difficult to dissipate and disappear, the more closer you are getting to the endpoint. So we're getting very close now. So we just drop by drop until it goes permanently pink. Okay, we've reached endpoint. We've got a permanent pink solution. So the sodium hydroxide and hydrochloric acid has reached that 1-to-1 equivalency endpoint. So now what I do is I record how much liquid I have used in my burette in the same way as I originally zeroed it. So reading my burette, I've added 34.2. So now I'm going to record and calculate the concentration of hydrochloric acid. So the starting volume was 6 and I added 34.2 mLs. So that equals 28.2 mils. So I've added 28.2 mLs of sodium hydroxide. Next is the concentration of sodium hydroxide is 0.1 molar. And then the volume of hydrochloric acid solution that I used was 25 mLs. So there's this formula that I can use. Concentration of sodium hydroxide times volume of sodium hydroxide equals concentration of hydrochloric acid times the volume of hydrochloric acid. So I can rearrange that formula in that the concentration of hydrochloric acid equals concentration of sodium hydroxide, which is 0.1, times the volume, which was 28.2, over the volume of hydrochloric acid, which was 25, and that calculates to 0.11 moles. So that is very good, and we are very close to a 1-to-1 ratio, which is what we're looking at. 0.1 of sodium hydroxide neutralizes 0.1 of HCl. Well, I hope you enjoyed that simple demonstration of the analytical technique called titration and the demonstration of an acid-base titration. As I already have mentioned, titration is a powerful analytical technique and is widely used in chemistry and various industries to determine the concentration of a substance in a solution in a very fast, very cheap fashion. Performing a titration is very inexpensive compared to all the other analytical tools and instruments that could potentially be used. The titration is still used today. This very day, titrations are still in use because of their inexpensive and quick nature. Examples where titration are still being used today in industry is in water quality. And it's used in water quality to determine the concentration of ions such as calcium and magnesium ions to determine water hardness. It is also used in determining the concentration of redox active substances, common in determining concentration of chlorine and hydrogen peroxide or iron in industrial and environmental samples. And also, and very importantly, it is used in the analysis of pharmaceutical compounds. Titration is frequently used in the pharmaceutical industry to determine the concentration of active pharmaceutical ingredients in drugs and formulation. And I personally use titration all the time. Many years ago, when I just graduated, worked in pharmaceutical, and I used titration nearly every day of my work to analyze and to determine the concentration of active drug ingredients. And like I said, it is still used today. And also, titrations are used in the food and beverage industry and is often used to measure the acidity of various food products such as fruit, juices, wine, and vinegar. We will come back to titration again in future videos where I will be demonstrating the use of titrations in more complex experiments. So please watch out for those videos coming soon. Well, thank you for watching, and I hope you enjoyed today's video. Please hit the subscribe button. It doesn't cost you anything, and it helps to support my channel and keeps me producing and experimenting for you. Also, check out my Patreon page where I have exclusive videos of experiments that will not be shown on my YouTube channel. I also publish all the recipes and background notes to every experiment that I do, both on my Patreon page and on YouTube, so you can follow at home. Please also send me emails with your questions, your comments, even your photos and videos of you doing home experiments yourself. Let's build a community of home experimenters. Well, with that, thank you again for watching. Until next time, keep on experimenting. Goodbye, everybody.